Welcome all. Today we are going to see another topic of our chapter number 5, which is air conditioning system. So this is the last concept and as evaporator. So before this, just take a short revision on what we did in this complete lecture. In this lecture we saw about the air conditioning system. We start this chapter with the types of air conditioning system. With types of air conditioning system, it comes as summer air conditioning system, winter air conditioning system. Then we saw central air conditioning system, split air conditioning, unitary air conditioning system. Then here we see types of central air conditioning system, direct expansion type and indirect. Then we saw compressor, types of compressor. We see the PV diagram of single reciprocating compressor. Then along with its working, now we see is the condenser, types of condenser, working of condenser. Along with this we see yesterday evaporator also. So evaporator, flooded time and direct expansion types. The top name of the today's topic is expansion device. Just focus on your screen. What is expansion device? You know, expansion device is working between the where it is working. Expansion device works between the condenser and evaporator. Expansion device separates the system by high pressure system and low pressure system. You can see one side of expansion wall is high pressure, another side is low pressure. So here we start with the definition of expansion system. You can read on the screen. It is a device which regulates liquid refrigerant to evaporator. It also divides high pressure and low pressure side of refrigeration system. Okay. Now listing its function. It reduces the pressure of refrigerant coming from condenser and temperature as per the requirement of system. It regulates the flow of refrigerant as per the need of load of evaporator. The various types of evaporator can be listed as capillary tube, then expansion device, valve or pressure control, thermostatic expansion valve, then high side float valve and low side float valve. Here you can see the first type of expansion device, which is capillary tube. What is capillary tube? You saw it many times in our RAC lab also. There is expansion device in the form of capillary tube. It's kept there. Capillary tube is normally it is a coil type structure, as I am showing here, where the liquid from condenser is moved in, and after the number of coils, number of turns, it is supplied this liquid to the evaporator. What actually these coils are provided? These coils are provided to increase the area and reduce the pressure, and this low pressure liquid is then fed to the evaporator, where it's evaporate and further things, you know. Now you can see in description about capillary tube here. Capillary tube is an expansion device. It is a coil or length of fine tube, has very small orifice, usually 0.5 to 2.5 to 2.25 mm inside diameter, and length is about 0.5 to 5 meter. So you can see this diameter of this capillary tube is very small. It is range between 5 mm to 2.25 mm. So you can consider it is a very having small diameter, but its length is very high, which is 0.5 to 5 meter. So you can see that there is an increase in the area and reduction in pressure. Capillary tube reduces the pressure of liquid refrigerant. This low pressure, low temperature liquid is moved to the evaporator then. Okay. Again I am going to explain capillary tube. Capillary tube, it controls the flow of refrigerant into evaporator. It is used with small hermetic units such as room air containers, and its application extends up to the refrigeration capacity 10 kilowatt. The usual form of capillary tube is installed in refrigerating plant. One end of capillary tube is connected to the filter and other end is connected to condenser. The other end is connected to the evaporator. The capillary tube reduces the pressure of refrigerant from high side pressure to low side pressure. Liquid refrigerant from condenser enters the capillary tube as shown in the figure through the tube. Here you can see it. Okay. The capillary tube replaces thermostatic expansion valve for small units such as domestic refrigerator, room air conditioner, and deep freezer. In our household refrigerator system, capillary tube is present. You can see it. Then coming to the advantages of capillary tube. It is simple in construction and requires no maintenance. Second one, when the compressor stops, the refrigerant continues to flow from high pressure side to low pressure side unless pressure is equalized. Third one, this requires low starting torque to start the compressor. So a lower starting torque motor can be used with this unit. No receiver is required for system using this device. Its cost is much less than compared to the other device. Actually, it is not having much more component. Just a simple coil having number of turns are used. So it is cheap in its cost. Then disadvantages of capillary tube. The refrigerant must be free from moisture and dirt, otherwise it will choke the tube and stop the flow of refrigerant. Second one, it cannot be used with high fluctuating loads. Third one, it can be used only as hermetically sealed compressor. It is not suitable for changing load conditions. Applications of capillary tube can be stated that domestic refrigerator, water cooler, room and air conditioner. Where the load is small up to 10 kilowatt, we can use the capillary tube as expansion device. Hope you understand this capillary tube. In exam many times this question can be asked for the 6 marks. 6 marks. Here is another topic of this concept which is named as thermostatic expansion valve. Thermostatic expansion valve, it is an important topic. It is in short form. It is also stated as TEV. In examination you will get a question such as draw the neat diagram of TEV and explain its working. What are the limitations of TEV? TEV means thermal expansion valve. T for thermal, E for expansion and V for valve. This question is the important one. Many times they are asked this question for 6 marks. So here you can see the diagram. In the name itself it states that thermal expansion valve means it directly depends on with the temperature. Being the word thermal is used, so using this temperature you are going to operate this expansion valve. Okay. So let's start with the construction. What is actually it consists? So this thermostatic expansion valve, it consists of the needle valve. Here you can see this is the needle, which is needle along with this needle strand, and you can see this from this entry high pressure liquid from condenser is coming in, and from this way it is moving toward the evaporator, and this is the entry for this refrigerant entry. You can make this entry or block this entry by just opening and closing of this needle stand or needle valve. Okay, so just normally what happens, this high pressure liquid from condenser is come here, then when this valve is open it goes to this side and then it moves to the evaporator. And you know what happens in evaporator, this liquid gets evaporated and it comes in the form of vapors, which may be a superheated vapor. These superheated vapors are then sent to the compressor. So this is the suction line. Okay, so how this So how this wall actually works is we are going to study here. Okay. This walls completely depend on this opening and closing of this needle wall. So how this needle wall open and close is depend on the temperature, which is sensed by this power fluid which contains in the filler bulb. This filler bulb is connected to this to here on the top of this below, and the next end of this below is connected to the needle, and this needle is connected to the adjustable screw. Okay. You can see here this pressure exerted by this power fluid is we name it as F of E, and the pressure exerted by the needle using this adjustable screw is named as F of E. Then here you can see the components of this thermostatic expansion valve. First component is a needle stand along with needle wall, then below, and the filler bulb and capillary tube along with this power fluid. Okay, hope you are getting what I am trying to explain here. Here we goes to see what how actually thermostatic expansion valve works. Thermostatic expansion valve maintain constant degree of superheat at the exit of evaporator. It directly work on this superheated vapor which are coming from this evaporator to this suction line, and its temperature is sensed by this power fluid in the fluid bulb. So it maintains this degree of superheat at the exit of evaporator. The filler bulb, I already show you that the filler bulb is connected at the end of evaporator, i.e. at suction line, which sends the temperature of superheated vapor coming out of evaporator. Filler bulbs contains power fluid. I already shows you this power fluid in this filler bulb. Here F of P is the force exerted by the power fluid on top of below, and F of E is the force exerted by below on the opposite to F of P. This power fluid sends the temperature coming out from the evaporator. Then you can see here at the equilibrium condition, when F of P is equals to F of E, then the valve is closed. Okay. Here you can see that when F of P and F of E, when this F of P and F of E are equilibrium, at that time this valve is closed. Okay. So here we are going to consider the case 1. When temperature of superheated vapor leaving evaporator increases more than the desired, then the power fluid senses the temperature and its temperature increases. Okay, as its temperature increases, its pressure also increases, because pressure is directly proportional to temperature. Also increase in pressure also increases its force. So you can we know that force is directly proportional to pressure, so F of P goes on increasing. So F of P becomes greater than F of E. At that time the below goes downside and the valve opens, causes to entry of liquid refrigerant to the evaporator. Here we comes to the diagram again. Here you can see that when the more superheated vapors are coming out through this evaporator, then this power fluid from this filler bulb senses this temperature. As this temperature increases, the pressure inside this capillary tube along with the filler bulb also increases. As the pressure increases, this force F of P also increases, and when F of P becomes greater than F of E, it forces this below down and the below goes downside, causing this needle to go downside and causes to open it. Due to this, the liquid refrigerant starts moving toward the evaporator. Okay, simple one. Now we are going to study this case 2. What case 2 is going to say? Due to the this is when the valve is open. Due to this entry of liquid refrigerant, the temperature of evaporator and vapor leaving the evaporator decreases. You know, when the liquid refrigerant enters the evaporator, then it evaporating, and by absorbing the temperature inside the evaporator and temperature drops. This decreases the temperature is sensed by the power fluid in filler bulb again. As the temperature decreases, its pressure also decreases. As pressure is directly proportional to temperature, now its force F of P also decreases as force is directly proportional to pressure. So F of P becomes less than F of E. At this time, below starts to move upward and needle wall starts closing, restricting the entry of liquid refrigerant to evaporator, and wall get closed. How this happens? Just come to the diagram again. Here you can see that when this liquid refrigerant start entering the evaporator, the temperature of evaporator decreases. This less temperature of evaporator and the vapor is sensed by the power fluid in filler bulb. As its temperature decreases, the fluid temperature also decreases. As temperature decreases, the pressure of fluid in filler bulb also decreases. As pressure decreases, its temperature pressure decreases, its force F of P also decreases. When F of P becomes less than F of E, at this time this below starts to go up. When the below starts to go up, this needle comes to its initial position, starts closing the wall, and the entry of this liquid refrigerant is restricted here, so that no liquid is going to further inside. In this way the wall stops here. Again, after some time, this liquid the vapors coming out of this evaporator again becomes superheated. Its temperature increases beyond the limit. Then this temperature again sensed by the power fluid pressure temperature increases. Because of temperature increases, pressure increases, then force also increases. This F of P again become greater, forcing the below to goes down, causes to open the wall, and the cycle continues here. Hope you understand the today's topic. Now I am going to show you the how this thermostatic expansion valve works in practical life. So we are coming here.
Hey there guys, Paul here from the engineeringmindset.com. In this video we're going to be looking inside one of these, the thermal expansion valve by Danfoss. Coming up, where do we find them, what are they used for, and then we'll cut one open and discuss the internal components and how they work. If you want to get the most out of any thermal expansion valve, then you should definitely check out the TEV Superheat Tuner. It's a free mobile. You can do a refrigeration cycle. In this model, which is a T2 thermal expansion valve, we have the main body, which is made from brass. On the body, we have the refrigerant inlet at the bottom of the valve, then the refrigerant outlet at the side. And on the other side, we have a cap which can be removed. Under that cap is a screw which is used to manually adjust the superheat. We'll see how that works later on in this video. On the top, we have this large head called the power head. There's also a coil of very thin tubing known as the capillary tube, and there is a large bulb at the end of it known as the sensing bulb. These are all made from stainless steel. The coil is stretched out so that the bulb sits at the exit of the evaporator to sense the superheat. We have previously covered in great detail how thermal expansion valves and electronic expansion valves work, as well as the different types of expansion valves used on chillers. Do check those out, links are in the video description below. What are expansion valves used for? Expansion valves control the flow of refrigerant into the evaporator in response to the cooling load. They measure the superheat at the outlet and react to this, increasing or decreasing the amount of refrigerant flowing into the evaporator to try and maintain a constant superheat. This also ensures that the refrigerant is boiling off and it will leave the evaporator as a slightly superheated vapor and prevent liquid refrigerant entering the compressor. Liquids cannot be compressed, so if they enter the compressor, this can cause severe damage and even destroy it. The bulb is filled with a refrigerant which is kept completely separate to the refrigerant in the rest of the system. These two refrigerants never meet or mix, they are always separated. The superheat boils the refrigerant inside the bulb, and as it boils, it creates pressure. The pressure travels along the hollow capillary tube and into the power head. The power head controls the flow of refrigerant, and we'll see inside that later in this video. We place a removable cartridge inside the inlet of the expansion valve. This has an orifice which works with the valve to control the flow of refrigerant. There are different sized ones depending on the cooling capacity and the refrigerant being used. Okay, enough about that, let's cut it open and look inside. I'll just put the valve into a bench vise to keep it steady while I cut it open. Because of the delicate parts inside, I'm going to use a hacksaw to cut this one open. It does take a little longer, but the angle grinder could rip apart the internals, and I want to be able to show you these parts. Okay, that's the first cut done. I'll just rotate that in the vise to cut the other side open. Again, I'm just going to use the hacksaw here to cut through it. That's pretty much cut now. I'll just use a chisel to snap the last little bit inside. And there we go. So let's have a closer look inside. So we have the main body which holds everything together. We have the refrigerant inlet coming in from the bottom of the main body in this vertical pipe, and then the refrigerant outlet on this horizontal pipe. So the refrigerant comes from the condenser and enters the valve body via the inlet. It enters as a high pressure, medium temperature saturated liquid. It then passes through the valve body, and when it leaves, it exits the valve through the outlet and will now be a low pressure, low temperature liquid vapor mixture. So what's causing the change in pressure, temperature, phase, and also controlling the flow of refrigerant? Well, we can see this small pin here. This is connected to the diaphragm up in the power head. The diaphragm is a thin sheet of flexible metal. As the diaphragm moves up and down, it causes the pin to move up and down also. Underneath the diaphragm, we have a spring which is pushing up against the diaphragm. We can use this to adjust the superheat, and we'll look at that a bit later in this video. Above the diaphragm, we have this empty chamber which is connected to the capillary tube and then the sensing bulb. The chamber, the capillary tube and the bulb are all hollow. I'll just cut through the sensing bulb using an angle grinder to show you the inside. As you can see, it's just an empty cylinder which is usually filled with some refrigerant. The refrigerant in the bulb and capillary are completely separated from the main refrigerant which flows in the system. This isolated refrigerant only moves between the bulb, the capillary tube and the top of the diaphragm. The sensing bulb sits at the outlet of the evaporator. As the cooling load on the evaporator increases, the superheat increases at the evaporator outlet. Because the sensing bulb is in direct contact with the pipe at the evaporator outlet, the thermal energy transfers and causes the refrigerant inside the sensing bulb to expand and boil. Because the sensing bulb, capillary tube and the chamber are all hollow and are a sealed system, as the refrigerant expands and boils, it causes the pressure inside to increase. This pressure travels along the capillary tube and makes its way to the chamber above the diaphragm. As the pressure increases, it pushes down on the diaphragm, and this pushes down on the pin. The pin controls how much refrigerant can flow, but to do that we need one more part. Inside the inlet of the valve we place an orifice assembly. Inside is a small strainer which protects the valve from blockages. Then there's a small orifice or hole which is blocked by a spring-loaded stopper. Our pin in the main valve pushes down on this stopper to open the valve. The further the stopper is pushed down, the more refrigerant can flow. As the cooling load increases on the evaporator, the superheat increases at the outlet. The sensing bulb at the outlet detects this, and the refrigerant inside boils, causing an increase in pressure along the capillary tube. This pressure pushes the diaphragm down, and that pushes the pin down, which opens the valve and lets more refrigerant flow. As more refrigerant flows, the superheat decreases, and so the pressure in the sensing bulb and capillary tube decreases, which means there's less pressure pushing the diaphragm down. The spring then pushes the diaphragm back up, which causes the pin to move up, and as the pin rises, the spring-loaded stopper begins to close the orifice, which reduces the amount of refrigerant that can flow. This repeats constantly and stabilizes the valve to ensure the correct amount of refrigerant can flow. We mentioned earlier about adjusting the superheat control. Well, this plug on the side is threaded internally, and if we rotate this, we can move the slider up or down depending on which way you rotate it. As the slider moves up and down, it changes how much force the spring is applying to the underside of the diaphragm, which changes the sensitivity of the device and allows you to therefore tune the expansion valve and adjust the superheat. I just want to remind you that you can download the TXV Superheat Tuner app for free by clicking on the link in the video description.
Hope you understand today's topic. Stay home, stay safe, and hope to see you soon. We will see the next topic in next another lecture.